Hello and welcome to the Analytics Forum. My name is Arnaud Varin. I'm a senior product manager at Spotfire.
Hi, and I'm Neil Kanunga. I'm a data scientist, and thank you for joining our session today.
Our session today is about Spotfire Geoanalytics. We will explore how new spatial data functions can be used to analyze data further in a geographical context to gain deeper insights and more informed decisions. Here's our disclaimer slide. As a reminder, the following information and presentation belongs to Spotfire software. Spotfire. What is Spotfire? What makes Spotfire different? Spotfire is what we call a full spectrum analytics platform. We see Spotfire being used every day, both by business users and also really advanced users, analysts, data scientists, engineers, researchers. Spotfire is powerful and enterprise grade, from simple dashboards and reports to mass insight sharing and real-time operational scientific analytics. With Spotfire, we bring one single modern experience for self-service analytics, data visualizations and dashboards, automatized reports and distribution of reports, advanced analytics and data science, analytics apps that may be consumed by thousands of users, and on-the-field use of analytics on mobile devices. All through one single platform. And now, since Spotfire 12, with ability to perform actions directly from visuals into virtually any external endpoint, all without leaving Spotfire. And where Spotfire really shines is in immersive and interactive visual data exploration from any type of data: static data, data in real time, in memory, in database, trained data as well, and in any combination. Now, when it comes to spatial insights, we believe Spotfire has the leading capabilities among other BI tools on the market, bringing you to location-based insights the easy way, without the learning curve of GIS, but still providing the depth and analytics capabilities to do predictions and optimizations through location. Spotfire connects seamlessly to spatial data, GIS, map services, map images, so you get insights quickly in the context of a geographical map, where you can include multiple layers of data, layers from different data sources that are interactive with each other, and other charts as well, and that provide more context to your data and will highlight spatial relationships between them. And this concept of data layers can be used not only for geographical data analysis, but also non-geographical data like process diagrams, schematics, and high-precision mapping down to the micron, like, for instance, for defect detection on silicon wafers. And then with Spotfire, you benefit not only from high-precision location-based insights, but you can also easily build user-friendly location-centric applications to help business users perform their jobs faster, easier, and with higher quality. And Spotfire is extensible. You can use spatial data functions to even better understand where things happen, why they happen there, moving beyond simple map visualization by using the location information, distances, spatial interactions with the data to analyze and apply learnings and get to new spatial insights. Data functions are no-code, reusable building blocks that add new capabilities to Spotfire, from simple data preparation, data enrichment, cleansing, geocoding, geofencing, to more advanced operations using AI, machine learning, and predictive models. And these tools, data functions, are usable by anyone through a simple-to-use point-and-click experience, without writing a line of code or being an expert. We have over 60 data functions, transformations, statistical tools available in various categories today. And a large portion of this is on spatial. We have a bit more than 20 spatial data functions available, adding spatial statistics, enrichments, transformations, computations, and also more types of spatial visualizations to Spotfire. And recently, we added 5 new spatial data functions that Neil will demo now. Neil, it's up to you.
Thank you, Arnaud. We have 5 data functions we're going to show today that show the breadth of that data integration you talked about, as well as the building of analytics apps and geospatial analytics. So with our first data function, we're going to be doing a distance matrix. And distance matrix is pairwise distance calculations from 2 different spatial data sets. So you have a table of data with locations. Here we have Airbnb listings that are shown with latitude and longitude coordinates and the name of the Airbnbs. And let's say that we were visiting a loved one in a hospital and we wanted to find the distances between the nearest hospitals in this data set, which is in Boston, Massachusetts. We have another data set with hospitals and their latitude and longitude locations. And we can go into our flyout and we can arrange our distance matrix data function by first going to our Airbnb listings data set. We select our latitude column. Then we select our longitude column from that data set. And then we select an identifier such as name in there. And next, we're going to select the hospitals data set. We're going to select the latitude column. We're going to select the longitude column from the hospitals data set. And I'll select longitude here. And lastly, we need to identify the hospital. So we'll do the hospital's name column. So we have 2 different data tables. And I'm going to hit OK. And that's going to quickly calculate the pairwise distances between each of these 2 data tables and locations. And I can visualize this on a distance matrix data table visualization. So we see latitude, longitude, and ID X. That's the first data table. And this is showing the first Airbnb in the list. And then we have latitude, longitude, and ID Y. And that's showing each individual hospital. And so we see pairwise comparisons. Now, the distance column in the middle is the distance in meters, and this is using the Habersign distance calculation, and that takes into account the curvature of the Earth. It's a very accurate calculation. We can sort this by the shortest distances and find the closest hospitals to the closest Airbnbs and see this sorted, but we're getting all of the different combinations here shown throughout the data table for other computation. Now, next is a spatial join, and this is similar to the distance matrix, except we're going to have a buffer distance. And why do you want to have a buffer distance? A buffer distance allows us to find the locations that are from one data table that are nearest to locations in another data table within a certain range. And this can be useful for finding proximity, but also can be useful for joining data if you want to have something that's very close to another data set. Let's say you have 2 asset data tables with different names, but similar locations. You can look at those asset locations and join the data based off of a buffer distance of, let's say, 100 meters or so. So that is a good way to join different data tables that may come from different sources that you want to align spatially. So rather than doing column matches that you would do in a normal data table, a normal data table join, you're going to do it spatially. So let's take a look at how this works. We have the Airbnbs shown in the circles, and we have the plus signs are the hospitals. And we can see the distance from the hospitals to the Airbnbs on the right. This is just shown in a data table. Then we have a buffer distance specified here where I can increase the buffer distance and it'll recompute the spatial join. So now we're doing a little over 2,000 meters. I can make that smaller to about 380 meters, and we're going to see a buffer range around each hospital to the nearest Airbnbs within 380 meters. So this is useful for finding, again, those that are within proximity. I can continue to adjust these and see the Airbnbs that are within that range. Now, to set this up, you simply go to your spatial join data function in the flyout. These can be added from your library. And you need to, similarly to the distance matrix, you need to set up the first layer, the second layer, and then in addition, you're going to need to set up a distance buffer as well. So the first layer, the distance buffer at the bottom allows you to set that, that proximity in that range. And what it's going to do is generate a data table here. We're going to looking in the data canvas of the data function. I've used a document property so I can have a slider, but you can use a fixed value. And that's going to generate a data table with same thing, latitude, longitude, and ID X for the first data table, latitude, longitude, and ID Y for the second data table right here. And then in the center, we have the distances between those all filtered to that buffer distance. Next, let's talk about nearest neighbors. So if I just want to know what is the nearest point from one data table to another data table from location data points, I don't necessarily want to see all the distance combinations, and I don't want to see the multiple matches within a buffer distance. I just want the nearest one. I have my Airbnb listings and my hospital listings. And here in the dark circles, you're going to see the Airbnbs, and the red pluses are the hospitals. So when I zoom in, you'll see these lines that are drawn from the hospital to the nearest Airbnb. And that's another data table that comes out of this data function. This data function is actually going to generate two data tables, one for visualizing the lines and one for just the computation. So the computation has a source longitude and source latitude, and the found longitude and found latitude. So that's your source data table and where those locations are, and that's going to go to the found nearest longitude and latitude. And so this is showing Airbnbs that are closest to each hospital. So you have the name of the hospital on the left, and then you have the name of the nearest Airbnb on the right there. And so I can set this up, and when I run this, I'm actually going to get two data tables. I'm going to get the nearest neighbors data table with the source longitude, source latitude, found longitude, and found latitude. And that's can be joined back into your data if you want to have the names of the Airbnbs and hospitals in our case. And then we also have this table of line connections, which has a source and found column and just the latitude and longitudes of those points. And now that data table is simply created just for drawing these lines if you'd like to draw these lines. So there's two data layers. There's the nearest neighbors output, and this we just set up with a found longitude and found latitude, and that's going to show, that allows us to mark the nearest neighbors if we'd like. And then there's another layer here with the line connections data table, and the line connections data table has we go to our line connection setting, and we use a line ID column, and then we go into positioning, and we use a longitude and latitude column, and make sure on the data you have the line connections data table, and that's going to automatically draw those lines for the map. And to configure this, it's very simple. You just go into your data function flyout. You select your longitude from your first data table. You select your latitude from your second data table. Your latitude from your first data table as well. Then you go to your second data table, and you go to your latitude and longitude coordinates as well. And this is going to do a computation across all of those combinations and find which ones are your nearest neighbors. Next, we're going to talk about lines to points. So this is a geospatial transformation data function that takes line geometries and converts them to points. And this is useful for if you need to compute the nearest point along a line to another reference point, or if you'd like to interpolate values of a certain measure along a line, or if you're trying to do other logistics operations and you need to find these points that are along the line rather than having one line as a data row in your data table. So here we can see these rivers in Scotland, and we see that there are these rows with the actual line geometries and a unique identifier. And when I click on the line, it's going to convert that into a set of points. And now that point has the unique identifier of the river, the latitude and longitude coordinates of each point, and the measure along the line. And I can select a certain granularity. So what this is going to do, what the data function does is extract the vertices along the lines for points, and that gives me the shape of the line. But then I want the points that are between the vertices, and I can set a maximum granularity. So what I'm doing here is allowing the data function to do more granular data. I can bring this down into, like, let's say 300 meters, and this will give a maximum distance of 300 meters between the points, or I can bring it down to 50 meters, and this will give a maximum distance of 50 meters between the points, so I can get higher and lower granularity from this. And configuring this is very simple. You go into your flyout, you go into convert lines to points. You have identifiers, which here is our identifier column of our rivers. So you just need a unique identifier for each of your line geometries. You need to set your line geometry column in there. And then you can do a granularity, which you can do as a fixed value, or here I've used a document property, so I can create a slider on my application and do it that way. All right, now our last data function is exporting to shapefile. Now this is very useful when you are generating geometries in Spotfire, such as Voronoi polygons and contours, or you have subsets of other shapefile geometries that you've been working with in your analytics application, and you want to export those for use into other GIS applications. So what we can do with this is I've set up a little input field just for a demonstration of a folder path, and I have that folder path, and I have a button to export the shapefile. The shapefile export data function is very simple. You just need to put in your geometry column. You also will have to install the WKB, RGDAL, and SP packages for R. Just make sure you have those installed. But then you just select your data table and the geometries. You select the attributes from your data table that you want to bring over. So aside from the geometries, what are the other columns that you want to keep in your shapefile? So you can select a wide range of columns here. You know, I can select all of them, or I can select just up to state SPIPS numeric. You don't want to select the geometry column because you already have that selected before. So here's just the attributes columns for my data table. And you can see those there. And then in my export folder, I have this set up again as a document property input field just for brevity. So I have an export path, but you can just manually type an export path there if you'd like, or you can tie it to an input field in the text area like I've done. And now geometry types, you can only export, shapefiles can only be points, lines, or polygons. And so you have to select whether you want it to be a point, line, or polygon. And you'll see that this exports really quickly. It's that background progress completed faster than we could even click on it. It exported the files very quickly to my desktop, where I can see the shapefile. Now, shapefile is 4 different files. That actually is a shapefile. There's a projection a shapefile, there's a DBF file, and there's a .shp file. And I can actually bring this .shp file into QGIS, which is an open source GIS tool. And now you're seeing this shapefile from my Spotfire analysis here. And if I wanted to see the attribute columns that I also exported, I can go to Open Attribute Table, and those are the attribute columns from my Spotfire data table as well. They're brought in to the GIS application, and I can do further GIS transformations and computations if I want, using whichever GIS tool I'd like that takes shapefiles. So thank you for watching these demos, and hope you found value in them. I'm going to pass it back over to you, Arnaud.
Awesome. Thank you, Neil. Distance matrix, nearest neighbors, spatial joints, line to points. These are fundamental tools in location analytics, now available in Spotfire. And I think these demos, again, demonstrate how Spotfire goes beyond simple maps. Spotfire really helps understand where and why situations happen there in an immersive, high precision, real-time fashion to get from data to insights in the fastest time in a spatial context. Now, to wrap things up, and if you want to learn more about Spotfire Geoanalytics, here are some key resources. First, with the Spotfire data function library, this is where you'll get access to all data functions, including the 5 new data functions presented by Neil. Then the TIBCO community website to skill up quickly with Spotfire, find new visualizations, data functions, templates. That's also the place where you can ask questions, find answers, share your expertise on Spotfire, and engage with the community. And that's also the place to make your user voice heard by submitting IDs or by voting on the product IDs that you want most. We also have regular Dr. Spotfire sessions on YouTube with José, who provides great tips and help for all things Spotfire. And of course, our What's New pages, where you can learn what's new in each Spotfire release. Thanks for watching. Enjoy TAF.
Thank you.